Hello, my name is Landon and this video is on electrochemistry, a voltaic cell drawing and use as an electrolytic cell. This video will include a real-life demonstration of our calculated voltaic cell being used as an electrolytic cell, specifically to copper plate a quarter. Alright, let's begin. So first of all, let's go ahead and start with both half reactions of the two metals we'll be using. The nickel, which is involved with the quarter, and the copper, which is going to be involved with the copper pipe we're going to use. These right now are both written as reduction reactions, and that's all right, because we can tell which one is going to act as the oxidation reaction by which one is more negative. I have handily wrote that right here. Since this one is more negative, it will act as the oxidation reaction, and since this one's more positive, it will act as the reduction reaction. With this, we can calculate the E0 cell value based off of the individual E0 values of each reduction reaction. We can say that the cathode minus the anode, so therefore that'll be 0.34 minus negative 0.257. Therefore, it's going to add it to it because of the negative. And from that, we get equals 0.0597. I'll just take that back and round that up to 0.6. From this, we can put this in here. I'll put 0.6 volts because this is where we kind of put our voltage of our voltaic cell. Now that we've got that value, we're going to move on to just labeling this pre-drawn diagram that I've already drawn, mainly for time's sake. So let's go ahead and label the different anode and cathode with the corresponding ions and metals. So we have the anode, which is associated with the nickel, and we have the cathode, which is associated with the copper. Now, which way are the electrons going to flow? This is determined by we go from negative to positive. And therefore, because the anode is negative, electrons are going to flow this way. So E minus, and they are going to go down this way. Since this is the case, and we've determined that the cathode is the reduction reaction, we should expect the ions that are in solution, so specifically copper 2+, to plate back on because of the added electrons coming down this way. So therefore, we will form copper metal out of the ions that are in this solution bath. Likewise is on the other side. We have nickel coming off of the electrode and falling into solution, losing its 2 electrons and staying as Ni2+ suspended in solution. Now that we're all done with the calculations and diagram drawing, let's go ahead and move over to a demo of the above voltaic cell as an electrolytic cell. Okay, so here is the demo. As we can see on the bench power supply, it says that the current limit's set to, this is an arbitrary value, I just picked that, and the voltage right now is at 1.2 volts max, meaning this should be about double the potential required to reverse the reaction in the opposite direction. And this current value is high enough to where it'll allow this voltage level to go up to a 1.2 volt level. Over here we can see the reaction setup. We have a copper brace in there. That's my choice for source of copper, and I have a copper coin. You can see it right there. This right here is just a mixture of copper sulfate, which I got from Rootkill. And yep, so all I have to do is press on. And as you can see, it's drawing about 37 milliamps at 1.2 volts. If you look close enough, you can see there's bubbling on the surface of that. I'm not gonna run this any longer because I know this is probably producing copper, or it is producing copper, but it's probably producing sulfur dioxide, and I'd rather not breathe that in. So yep, there's my electrochemical setup. Here's the copper coin after I plated it for the amount that you just saw. It's very, very hard to tell, but actually if you look, this side is Oh look, here's a good distinction. That line right there, you can see the part that was covered by the electrical tape and then the side that wasn't. So even just that brief time of it being on, it was able to electroplate a very thin layer of copper.
That is it for this video. Thanks for watching.